This is Basic Atari 8-Bit Podcast.
Hi, I'm Kevin Savitz, and this is a special interview edition of Antic, the Atari 8-Bit Podcast. Today's interview is with Mark Rustad. Mark worked at MECC, the Minnesota Educational Computing Consortium, where he developed the Classroom Star, which was a classroom networking hardware for the Atari 8-bit computers, which allowed several Ataris to boot from one machine. Up to 64 computers, actually, could boot from one host computer. And this was a product that was never released by Atari. Then he was hired by Atari. He worked at Atari from 1983 to 1984 as a systems project leader, where he worked on the Atari 1030 modem. He also worked on the PLATO educational computer system. This interview was conducted September 4, 2014 over Skype. In addition, Mark graciously provided some software, which I have uploaded to archive.org. There's a link to that in the show notes at ataripodcast.com. Files in the archive include files related to the 1030 modem, the Atari MECC library, program library that includes a bunch of stuff for the Atari Classroom Star, copies of a terminal emulator, and even more files and things, memos about the Atari Classroom Star. So enjoy that and enjoy the interview with Mark Rustad. Tell me how you got started at Atari.
Well, I first was exposed to the Atari home computers when I was working for MECC, the Minnesota Educational Computing Consortium. Most people recognize that as the source of the Oregon Trail program. And I was involved with working on the operating system of the time-sharing system that was connected to all the schools in the state. At that time, they had developed a lot of programs, including Oregon Trail, for the Apple computer. Oregon Trail actually began life as a basic program on Hewlett-Packard, and it also ran on the Cyber that was running the statewide network that I was working on. And of course, was ported to the Apple II in multiple incarnations. And Atari was interested in getting MECC's educational catalog put onto their computers. So they basically paid MECC to do that. And so that's where I first got exposed to it. I rather liked the Atari because compared to the original Apple II and Apple II Plus, it could do the simple thing of lowercase. That meant a lot to me. Of course, the later Apple IIe at least could do that, but that was even later. So yeah, the 400 and 800 came in then. I wrote some utilities to up and download to the Cyber on the Atari. I already had a cross-assembler for 6502 on the Cyber mainframe that supported a lot of MECC's development. It also did other architectures, 8080, Z80, 8085, most of the 8-bit processors. And that got a lot of use. Interestingly, I actually got in trouble for developing that. It wasn't a planned project, so I got dinged by one manager, and I got an award from another manager. So it kind of canceled out.
Right.
Yeah. Nevertheless, I did that work on my own time over a weekend, so actually none of them have anything to say about it. Anyway, so that's where I first got exposed to it, and I was asked by Ken Brumbach to try to develop a classroom network for the Atari. Now, I'm a software guy. When I was in high school for a while, I thought I was going to go into electrical engineering, but before I went to college, I figured out I was going to be all software. So this was actually the first piece of hardware I ever designed in my life. Designed a very simple circuit using RS-422, balanced communication, and essentially had a 8-port multiplexer that actually got built ultimately into you remember the 850 serial module? Okay, well, we used
Yes.
the same plastic shell and had 8 ports coming out of it. One port could go to each of 8 computers, and the server computer was also an Atari, and it used the joystick port to control which computer it was communicating with. The communication happened at 100 kilobits a second. The maximum Pokey could do was 128, but it couldn't sustain that with arbitrary screen DMA. 100 kilobits was the best that could keep up with any arbitrary display.
And if you blanked the screen, then I suppose you could get the full rate?
It wouldn't have to be blank. It was a matter of some of the graphics modes with sprites and all the stuff turned on. There was too much DMA going on to keep up. So you had to do something kind of exotic to make it fail, but you want stuff to just work, right?
So this gadget, what could you boot Ataris off the? You'd have like a bunch of diskless systems that would all boot off of one machine, or what would be the?
Yeah,
how is this used?
That's right. It was kind of a hack. The cassette. If you ever used a cassette on the Atari, you hold down the start button and turn on the power, and it goes, and you hit return. And I used the cassette boot to boot the computer. And what would happen is the host would recognize that the computer was in this state. I actually used the cassette motor control line to power the LAN interface. So the cassette motor coming on would activate the interface and would sit there silent, and the hub could recognize, oh, there's an active node that's not sending me anything. He must be trying to boot. And because of how the boot worked, it had a 6-second delay before it would be ready to receive any data. So the hub computer would keep track, okay, a node asked to be booted, and then 6 seconds later, it would begin sending data to it because it would be not listening until then. So it could keep on serving other nodes in the interim. After that, I'd send data down tone encoded, just like it would be from a cassette. So it would transmit the alternating frequency tones at 600 baud, just like a cassette, so it was quite slow. Mm-hmm. And the cassette tape format required an additional block to be an end of file. And I wasn't willing to pay the time penalty to do that. So I set the first block up to actually load into low memory of the computer so that I could initialize the low memory global to indicate that the end of file was received, so that one block would suffice. And that was enough code to bootstrap the network. So that would download enough code to turn around and download the rest of the DOS at 100 kilobits. Wow. Now, the DOS was actually based on Atari DOS. We got Atari to give us the source code. And I basically found a dividing line between the hub and between a node and a server. And I got it worked out so that the abstraction was that the result on the disk, and it was fully read and write capable, would be the same as if you did multiple opens on a single computer. So if you open the same file with 2 different paths on the same computer, and you'd get the same result as 2 computers doing it on the network. I figured I couldn't do any better than that with the available, protocols. For the most part, it was used to load programs. But because the thing was Atari DOS compatible, it worked with anything. So you could put in an Atari writer cartridge and boot the thing up and use it, albeit with more memory, because it wasn't as big as the full DOS. I
don't understand. Albeit with more memory.
Well, you'd have more memory available because effectively my DOS was smaller.
Oh, I see. So you'd have more memory for writing your word processing.
Yes.
I see.
Yes.
I see. Could it then save?
Absolutely.
Back to the the host machine?
Yeah, it was fully functional. We also shared printers. So you could print to a shared printer that way as well.
So if, say, student 1 saved a document, could he clobber student 2's work by using the same file name, or was it somehow kept separate?
No, it wasn't kept separate. It was, like I said, it did the same thing that, a program using multiple instances would happen on a single computer.
Okay, I understand.
Yeah, so it didn't solve any of those kind of problems. But that, for most uses, that wasn't important. The server used as much memory as possible as a cache. You might remember there was a product that had a 128K RAM card for the Atari 800, and there was code in there to support that. So it would use all of it as a cache, which was quite important because the floppy was so bloody slow. 19.2 just was abysmal. I remember the first day I demonstrated this thing for Atari, they couldn't believe it ran that fast. And they actually hooked a spectrum analyzer up to the thing and said, yep, 100 kilohertz going on here. And there was one fellow working there that I had encountered during a summer I spent working on PLATO when I was in high school. And so he remembered me, and he said, well, if Mark says it can do it, it can do it. And in fact, later, I learned that the reason all the peripherals ran at 19.2 was that was the fastest the Lear-Siegler ADM3 could go, and that's what they used to debug the communications. There was no technical reason for not going faster.
Wow.
Yeah, that's kind of sad.
That's disappointing. Yeah. Wow. So could the system boot multiple units could boot simultaneously, or was it a one at a time?
Well, they could be in the process of waiting to boot.
Okay, right.
That 6-second interval could be overlapped with any operation, and then there was enough time window that you could boot up a bunch of nodes, basically concurrently.
So it was. I'm sorry. Go ahead.
Oh, I was going to say, the network hub was designed to be daisy chainable, so you could have more than one set of 8. I don't know that anyone ever ran more than 16. I don't know, we might have run 32 once in the lab. I think we maybe did, just to see that it could work. And that was at Atari. And yeah, the executives at Atari were, well, let's say impressive in their own way. Ray Kassar's comment when he saw my network was, gosh, you have a lot of Sony TVs in here. Are they any good? Made a big impression. Now, the network was never produced by Atari, and I don't know precisely why. There was a competing network that came out of Atari's research group. I don't know much about it. It was considerably more expensive because it included a microprocessor. Mine included, like I said, RS-422 line drivers and receivers and some multiplexing logic. And I will admit it wasn't competently designed. It simply had a 7805 voltage regulator to power the whole thing, which ran rather hot. But it did work, and a number of schools in Minnesota used it.
So you designed this while you were at MECC?
Yes.
Okay.
Yes.
This is funny. So I did another interview today with David Small, who wrote about Ataris for many magazines.
Yes.
And so I'm just looking at articles he wrote. And at the end of an article in the July 84 issue of Creative Computing, it's mostly about something else. It says Star Network. Another interesting Atari product you may be hearing about is the Star Network. Allows up to 64 Atari computers to be tied to a common disk drive and printers. Makes it absolutely ideal for classroom situations.
Yeah. That's what I called it, the Classroom Star. I still have source code for it. Yeah. I called the file CSNOS, Classroom Star Network Operating System.
Excellent. Will you share that source code with the Atari community?
Well, I gave it to the museum.
Okay.
So Kurt Vendel certainly has a copy.
Okay, cool.
Let's see, what else can I say about it? When I was working on that code, I had a kind of unique experience. I had writer's block for the first time in my life. And I wouldn't wish it on anyone. For a period of maybe, I don't know, a couple of months, I couldn't write a line of code.
Wow. Just
completely blocked. Didn't understand what was going on. I couldn't draw a data structure. It was just all gone. And I bought myself a new stereo thinking that would, wake me up. I bought a new car, but, no, didn't help. And then one day, I remember this intensely. I was walking back to my office. My eyes happened to be on the waste can, and source code for the whole thing appeared in my head. In fact, it wasn't just source code. It was a printed listing. Unlike most listings, each page was exactly the right length. I ran to the console of the mainframe, and I sat and I typed for more than a day straight. And about a week later, we flew out to California to demonstrate it. It was done.
Wow.
I've never had anything like that happen before or since, gratefully. It's not my normal development process by any means. But apparently I couldn't program because all the resources were tied up. But no one told me. It was the scariest thing I've ever been through.
Wow.
But anyway,
and when your brain was done, it dumped it out, and that was it.
There was one typo found in it by Dennis Smith. One typo we found. But other than that, it was perfect.
It's amazing.
Yeah. You can't plan for these kinds of things. But like I said, I never want to go through that again because it was too terrifying.
You got a car and a stereo out of it, so...
I suppose. But that's how much I didn't understand what was going on.
Wow. So you're at MECC, and then how did you transition from there to Atari?
Well, Atari was interested in the network and made a deal with MECC to buy it. And they wanted me to go along with the deal. So I flew out to Atari, had an interview there. And only when I arrived did I discover that Sherwin Gooch, someone else I met on the PLATO project back when I was in high school, was actually going to be my boss. He was also leading the 1030 modem effort at the time. So that was interesting. Atari moved me from Minnesota to California, and I guess I'm grateful for that. Things were very interesting. I got to meet a whole lot of people. I was really joining Atari right at the high, if you can imagine that. And before terribly long, of course, things changed. There were a lot of layoffs, and they couldn't lay me off because I had a one-year contract. In fact, I couldn't leave, technically, without reimbursing part of the relocation expenses. Nevertheless, I did wind up leaving because I discovered a company working on two-way cable TV, which was something I was very much interested in, something I had been looking for myself for a couple of years. And so when a headhunter called me up and said she had that, at first I thought she was bluffing, just, chance to get to talk to me. But no, she had exactly what I was looking for. So I moved. And believe me, I saved the piece of paper that said we were even. They didn't collect on what I theoretically owed them.
It was only a month, right? I mean, you were there for 11 months, according to LinkedIn.
Yeah, it would have been 2 or 3 months. Yeah, it wouldn't have been that big a deal, but still. It turned out that was a good thing because after Jack Trammell took over, the nature of that deal was that all the payables were Warner's and all the collectibles were Jack's. So I could just imagine someone going through and figuring out, hey, this guy owes us, some money. But I saved the letter. So we're all even. So anyway.
So it says you were there in Atari from May 83 to March 84, approximately.
Yes.
Your title was Systems Project Leader.
Yeah.
It sounds nice and vague.
Yeah. I
And
was
you
a
were
programmer.
yeah. And you were basically working on the Star Network the whole time?
Oh, no. I worked on the 1030 modem. When I got there, that was the first project. Their DTMF dialing worked, but it wouldn't pass bell spec because there was too much noise in it. And I looked at it and discovered, well, there's a whole story. The 1030 modem actually generated the sine waves in the Atari. Well, if you know the Atari sound hardware, it can't do that. It can't generate sine waves. You can't dial a phone with square waves. But if you've studied Pokey really closely, there's this thing called volume-only mode, where you can turn the volume control into a digital analog converter, essentially. And that's what this did. It generated the tones using that. But wait, there's no sound output in the serial I/O port. That's also true. But there's a sound input. And it turns out sound generated in the computer leaks out that pin, something like 18 decibels down. So they just put an op-amp on it and sent it out the phone line.
Wow.
Yeah, so this thing had, I forget if it's 4 or 5-bit D to A converter. Yeah, 4 bits, I think. So he had this, really poor D to A converter, and of course it's not linear. It's really poor. Connected to, basically noise leaking out this line, and we're going to use it to dial the phone and pass bell spec.
Wow. All right, so I just want to make sure I'm clear. You're creating sine waves in the Atari using the Pokey's volume-only mode, and then it was leaking out somewhere, and you knew that was going to happen, so then you pulled it out into the modem that way.
Yes.
Okay, that's crazy.
That's just nuts. Yeah. But that's the product they had designed, at the time I was there. And, fine, I'm going to try and make it work. So I spent weeks listening to DTMF tones, and I finally figured out that it was using the horizontal sync to synchronize the samples, and it was taking too long. It wasn't quite keeping up. And that's where the noise was coming from. I finally figured out that you really didn't have to output a sample every scan line. Every other scan line would be enough. I'm not a DSP wizard, but even I could figure that out. So just backing off the rate by a factor of 2 bought me enough time to calculate, well, not calculate, just spit out the samples. And that made it almost good enough, but not quite. It still didn't pass, but it was a lot better. So I looked at it, and finally I'm looking at the sine wave sample in the code, and something about it just didn't look right. I wasn't sure what it was, but it just didn't look right. So I decided to calculate my own, calculated it on the Data General machine that they had there. And indeed, I got a different table than what was in there. And then I realized my predecessor, who wrote the original code, had calculated it using the sine function of the Atari Basic. And the microcomputer trig functions, both Apple's and Atari's, were lousy, just terrible. And so after I used my new sine function, then it was fine. Then it passed. And we had to test it with essentially a full range of configurations, because you might have a couple of disk drives and a printer in line with your modem, right? So we had to test with different daisy chain configurations, different computers, and the 1200XL had different sound characteristics because they removed the high-frequency filter because they wanted to claim a greater frequency range. Unfortunately, that lets a lot more noise out. You can't explain anything engineering to marketing. So, marketing got their way and the filter was removed. So I had to use different amplitude sine samples for the 1200. But despite all that, we were able to get the signal levels within the box specified by the Bell standard. Now, it turned out we were a tenth of a dB from each end in the worst cases.
Wow.
But we passed.
You just skirted it through.
just got,
Yeah.
and so, with all the impairments that I described earlier, it was that close. Now, that said, I spent so much time listening to DTMF tones, I realized that actually an awful lot of the products that were out there dialing the phone really didn't meet the standard. At the time, credit card terminals and stores, you'd hear them dialing. Those signals were mostly really awful. And if anybody actually tested them, they wouldn't pass. But, they worked anyway.
Wow. This is still back in the day when the phone company had a lot of control over what could and couldn't be plugged in, right?
Yes. Yeah. So like I said, a lot of those devices, if they were ever actually tested, would never pass. But the 1030 did.
Awesome. So you got that working, and then you were done? That was it?
Well, I did some work. I did do some work on the Classroom Star. One change that happened between MECC and Atari, at MECC we had actually three twisted pairs for each computer, and a change we made got it down to 2 pair, which is much more reasonable. Change the protocol a little bit. Anyway, that was a much better place to be. And what else? One of the new products, and I can't remember which one it was. Do you recall which product had a speech synthesizer in it?
There was a few of them. There's one called the Voice Box.
I think it was built into a computer.
The 1450 XLD.
Yeah, that's probably.
Never came out, but yeah.
Yeah, they had me take a program that was in the market that drove a speech synthesizer, and they wanted to take the front end of that and get it to work with their computer for demo purposes.
Okay.
So had to disassemble the program, take it apart, cut their back end out, put a back end for the computer in so they could do their demonstration. I didn't consider that entirely legitimate thing to do, but since it wasn't a product and just for demonstration, I did it.
Wow. What program did you have to disassemble? Do you remember?
Gosh, I don't remember. I don't want to remember, right?
Okay. What did it do? Was it a game? Was it?
No, it wasn't a game. They wanted a text to speech. It was something that did text to speech. That's about all I remember.
Okay, interesting. Huh. So you didn't have the source code. You just had to reverse engineer it.
Yes.
Huh. Interesting.
That's the way I usually engage with things anyway, from the bottom up. So, yeah.
So did you have one of those machines on your desk, the 1450s or the 1400s, whatever it was? Because
I'm trying to remember, and I don't. I mean, I remember doing the work. I may not have had an actual machine. I may have had some kind of mock-up. I don't think I had the real machine. I think I had some kind of, mock-up of it.
Those machines are kind of the holy grail of Atari machines. There's like a couple out there. People have a system board. There's a couple of full machines because it was never really. It was canceled before it was released. So people want stories about those. So that's why I'm asking.
Yeah. No, I probably never saw a real one myself.
So what was the company you left for? The cable company, the two-way cable company. What company was that?
It was called Packet Cable at the time, later changed its name to Packet Technologies. And ultimately, the cable technology they developed found its way, I believe, into LodgeNet. But there also was a part of the company called Packet Phone, and the technology they developed actually became Frame Relay. So that went on and did a little better. Had a whole, it was an education. You might remember back in the day, the cable companies were all regulated. And virtually every cable provider promised to provide two-way when it was feasible. So Packet Cable's business plan was to make it feasible because they've all promised to provide it, right?
Right.
And we had a very good system that it solved theft of signal problems. It solved really all kinds of problems for a cable company. But to install it, it was a full rebuild. You pretty much had to take everything out and replace it all. So it's not an inexpensive thing to do. After the first demonstration was done at NCTS, a big cable show in Las Vegas, within months of that, Congress deregulated the cable industry. So with the stroke of a pen, all those contracts that promised to provide two-way were thrown out.
Mm.
Interesting.
Yeah.
Phone stopped ringing. It's not possible to sell anything.
Man.
We did get a system installed in Cupertino, and we did a bunch of interesting things. We realized that we had access to data that was valuable because we could tell what channel you were watching, when you were watching it, whether you muted the sound. And of course, this is great for knowing what ads people watch.
Mm-hmm.
Figured that out right away. And so we put a lot of effort into gathering that data in a way that would maintain customer privacy. California had a very strong law at the time about the privacy end of it, so we took that really seriously. And we solved that problem, that even a malicious cable operator would not be able to extract data that could identify a subscriber. And we were very proud of that. We thought that was really good work. Even with that, that wasn't enough to overcome the cable operators' reluctance to spend money on their plan. Even though some of the cable systems had huge problems with cable converter boxes walking away, we completely solved that problem because the converter box that we had cost like $35. It was little more than an IR transceiver with a couple of LEDs and a numeric pad because it really didn't do anything. Everything was done outside the home. It could, however, tell you you had mail waiting. So you could actually read your email on your TV screen. You could send greeting cards. You could get stock quotes. It was hooked up to Videotron. It used a Naplips Videotex sort of thing, which was, well, the best thing at the time, pretty much. So it was quite an interesting system. Oh well. Got with Paul Barron there. He was the inventor of packet switching, and he was, I guess, chairman of the board of the company, founder, and so it was. That was a highlight. Working a bit with Paul Barron, met a lot of really good people at Packet Technologies. In fact, Sherwin wound up there as well.
Awesome. So you were going to tell me about the urinals at Atari. Yes.
And it tells the story of morale. When I joined Atari, there were, the color Apple logo stickers that came with Apple computers.
Sure.
Well, yes, precisely. Those were stuck in the men's urinals as targets. Okay. By the time I left Atari, they had been replaced with Atari logos.
Wow.
Yeah, I don't know who did that, but it tells a story, doesn't it?
Mm-hmm. Yeah. Well, I was going to ask you about the company culture. You read so you read stories about parties in the hot tub and people doing cocaine and this and that, and then every person I've interviewed seems to genuinely be like, no, I didn't see any of that. So I'm curious about what you saw.
I did not see any of that.
Sticking with the party line, I see. Of course, I'm interviewing programmers a lot, and they're just like, yeah, we're programmers. We're in the back typing all day,
I have no reason to believe it didn't happen. I mean, it's the only company I ever worked for that had a hot tub on site. There's a reason for that.
Yeah.
And there were stories about John Cavalier in the hot tub, but I never saw it. Well, no, I did see the hot tub once when it was unoccupied, one time. And that's all I know.
I see. Plausible deniability. I got it. All right. And kind of off the mark of what we're talking about, but you said you worked on PLATO. I'm interested in PLATO. If you could tell me a little bit about what that was like, working on that system.
Yeah, I got started actually on the PLATO 3 system, which predated the plasma terminals that are more iconic with PLATO. They put a terminal in my high school in Springfield, Illinois, only because we were close to the state capitol. And they were wondering what the kids would do with it. So we got to use it. Required a video feed all the way from Champaign. So the terminal consisted of a black and white TV and a keyboard. Did a whole lot with it. One of the things I did is I wrote a program to collect passwords. And the system allowed you to read memory anywhere. I spent a lot of time looking at memory, figuring stuff out. And the people running the system were so helpful, they sent me a partial listing of the source code of the system, which makes it much easier to find things in memory. Anyway, so I wrote a program that could see what terminals were idle. The system allows you to press keys on other terminals, so I could see a terminal that was idle and press keys on it to put it into my program. And then my program simulated the system displays. So they'd go type in their password, and then I'd send them off to the real system and save their password. I got in a little trouble for doing that. Well, and I say a little, and I'm not joking. They just called up and said, "Don't ever simulate a system display again." They didn't say don't hack don't log passwords. They said don't simulate displays. Don't simulate displays.
Right.
So okay, absolutely, I won't. And so the next time I gathered passwords, I was able to process the keys before the system could. And so I could tell when they were typing in a password, and I would just gather the keys, and I'd have their password. Much cleaner solution. And so that was the time they decided that they needed to hire me. So I spent the following summer, I was a sophomore in high school, becoming a junior, and I spent that summer in Champaign-Urbana working on the PLATO 3 system, while the staff focused on developing PLATO 4, which is what most people think of as PLATO these days. And so that was a fabulous summer. I learned a huge amount. And even got to do some things with the 6400 that PLATO 4 is being developed on. So I did more work on PLATO when I entered college. Well, I did work on PLATO all the way through high school. We would drive to Champaign-Urbana at every opportunity. And the game then became one of, we'll give you sign-on so that you can do system-level work after you break in and tell us how you did it. And so it became a kind of a game that way. And so a bunch of us would come and, we'd hack in and we'd tell them how we did it. And then they'd give us sign-ons and we'd do some work. And once we came and most of us went to the terminal room and we sent one person up to the fourth floor to tell them that we were there. And the person came back down and said, well, we're not going to be able to break in this time. They're just going to give us sign-ons. Well, I'd already broken in, flashing messages on the console saying Springfield High is here. And turned out they thought they'd locked all the doors, but no, they left one off the hinges. Actually, I write a certain keystroke at the right screen and you were in. It was that easy.
Wow.
No big deal. But, got to tell them about it. They had a PLATO at 50 event at the CHM, the Computer History Museum in Mountain View. And at the event, Dr. Bitzer, who ran the lab, said that after Springfield High exercised their security, they never had any more security problems for the life of the system.
Wow.
So, okay, that's kind of cool.
Awesome. All right, so back to Atari. Is there anything else? What should I have asked what do you want to tell me about Atari stuff that we haven't covered yet?
There was a lot going on there, but I'll say the management was pretty dysfunctional in quite a lot of ways. And probably some ways that I can't prove and can only speculate on. But I think there were some unpleasant things going on somewhere. I'll leave it at that. There were too many inconsistencies for there not to be. We had meetings with marketing trying to figure out what the next product should be for something. We'd say, well, what's our install base? What can we sell to? How many computers are out there? And marketing would give us a number, and we could sit down and the factory on the other side of the street made way more machines than that. Are you just counting warranty card returns? And they insisted, no, this is everything shipped up to yesterday. Really? Well, fine, but it suggests that something wasn't quite right somewhere. It just wasn't hard to figure that out. Apparently it was for others. The IT systems were kind of write-only. The person that was project manager for the 1030 modem wanted to get a listing of all the people that were charging time to his account. Every time card had to have all the hours assigned to different projects and things, and he could not get that. That seems like a really basic thing and entirely appropriate for the product manager to ask for, and he couldn't get it. And so that was the day I stopped doing my time card. I said, this clearly serves no useful purpose. Well, the secretary started doing it for me. Great. The data was probably no more meaningful than when I did it, or no less meaningful. But, why do it if it's a write-only system?
Right.
Doesn't make sense. So there was a lot of kind of crazy stuff. So, the parties, everything was crazy, I think. But like I said, I didn't see the parties. Well, I was at the beer bus. I had some of the beer, but there were, some kind of funny things that happened. It's an interesting environment. That we had a room that had some of the video games in it. Okay, and I think the favorite of most of us was Pole Position at the time. So Sherwin, again, you spend a little time in there driving Pole Position. Not the best thing to do right before you go home. And he had an RX-7 at the time. And so he wound up with a speeding ticket to prove it. And he attributed it directly to, playing Pole Position before he went home.
I've had that exact experience. You're playing a game in the arcade, then you just remind yourself as you're driving home, just calm down now.
Yeah, right. Yeah, exactly.
Well, if you could send a message to the Atari computer community that still exists, and you can right now, what would you tell them?
That's a good one. I've been thinking about it all day, and I really don't know. I guess I might say that the insides of the company was considerably messier than the beautiful computers that they produced. I remember the 400 and 800 as being really striking computers, incredibly well built, very rugged. Like I said, they won me over with lowercase. Compared to the Apple II of the time. The Apple II, you can plug stuff in and do stuff, more of that with it, but it was lacking in a lot of other ways. And I'll just say, the company was not as beautifully organized as the computers.
Excellent. Good answer. Thank you. So today you work at Intel, is that right?
Yes. Mm-hmm.
Can I ask what you do?
Well, I work on Ethernet drivers, 10 gig Ethernet drivers for Linux.
Awesome.
It's I've worked on low-level software my entire career, drivers, kernels, that sort of thing, the Atari network, and so I'm just continuing to do that, and I keep getting better at it, perhaps slowly, I don't know. I will say that the Linux kernel and its coding standards has improved my programming more than anything else I've ever done. And a lot of people point to it and say, well, it doesn't have enough comments. And all I'll say is Linus's comment that if your code needs comments, your code is crap, is a really good first-order approximation of the truth. That's largely true. So I've learned a lot from the Linux guys.
I guess my last question is the other thing I do besides these interviews is I'm working with archive.org. We're trying to collect as much old applications and software that might not be out there in the world public yet. So you mentioned some source code before. Do you have any Atari source code or any binaries that maybe haven't seen the light of day that do you have them? And if you so, would you be willing to share?
I have some source code, some from MECC. Do I have? I think the only thing I have from Atari is that DTMF dialing code, which I actually got from Kurt. Mm-hmm. And I'm not completely sure, looking at it, I don't think it was the final version, because it has a comment in there about needing different amplitude for the 1200 XL, but it isn't in the code. And I clearly remember it being in at least the final version of the code. So Kurt got a version of it. I don't think it was the final one. And I remember typing in, I remember typing in a game from a magazine. And it was that one where you'd capture areas on the screen, and they'd fill in, and these sparkly things would come and
Okay, so the real Atari game was Quicks, right?
Yes. Yeah.
From a magazine, who knows what.
Yeah, and I've got the source code for that that I typed in for building with my cross assembler that ran on the mainframe. And yeah, I think I can send anything I have. I don't really have very much. I don't have any Ataris anymore. I had a PLATO cartridge for a while, but I don't think I have that even anymore.
I have one around. It's not very useful without the service.
Service exists.
Does it? Really?
Yes.
I did not know that.
Yes. If you go to cyber1.org, you can get a free PLATO account.
Wow.
And, okay, here's the problem. The Atari wants to talk asynchronous. So you would have to have a terminal server to connect to the internet and feed you ASCII. A generic terminal server would be able to do that job because they do support the ASCII PLATO. I'm fairly well involved with that. I've actually, I don't know if you've seen, let's see, I'm at Intel now, so I have to kind of use Intel things. But the plasma terminals that PLATO 4 had speak a really bizarre 21-bit protocol. So I've taken a Galileo, this is an Intel Galileo board, and interfaced it to a PLATO 4 terminal. The Galileo does the translation between the internet and the 21-bit protocol. And so the terminals work perfectly with it.
Wow.
I also did, there was a box that could be attached to the PLATO 4 terminals. Most people call it the Gooch box because Sherwin Gooch invented it. Officially, I guess it's called the Gooch Synthetic Woodwind. It was a 4-voice square wave music box. It had 4 voices with volume control. And there's a fair amount of music available. So I decided to emulate the Gooch box inside the Galileo as well. So it generates the sound and feeds that out. And we're hoping to get a classroom, an entire classroom of these terminals set up at the Living Computer Museum up in Seattle.
Awesome.
They're more about having things interactive and working.
Mm-hmm.
And so they would be connected to the PLATO system on the internet, and it should be able to demonstrate all of the multiplayer games. I mean, I think it would be a great thing because they could have a multiplayer game night at the museum, and it's just so much more fun to be, playing Airfight or Empire when the guy you're shooting is, voice distance away.
Right. Well, that sounds amazing.
Yeah, and that's how it was done, at the University of Illinois. There'd be a bunch of people in a classroom, and sometimes people would be separated by distance, of course, but often there would be a group in a room, and a team flying in Empire. They used to be Klingons. Now they had to change the name to Khazars. Would often be in the same room, working as a team in the game. So I think it has a lot of opportunities for them to have events around it. And so a fellow named Aaron Wolfson has all these terminals. And so I've developed this interface, and after all the pieces come together, hopefully those terminals will be available in the museum there.
I'll have to make a trip up to Seattle to see that.
Yeah, and of course they do have Ataris there as well, of pretty much all stripes, I think. Everything they can get their hands on. And you can use them.
Awesome.
That's the great thing about that museum.
I was there before it opened. They had a website, but wasn't really open to the public yet. And so I called them up, and I was just like, hey, can I come see the museum? They're like, sure. What time? And I was just like, gave them the date and time I'd be there. And I showed up, and it was just me and the curator, the archivist, and someone else. And I had them for like 2 hours, and they just gave me a tour of like everything. And I was just like, it's a class place. It was pretty awesome.
Have the 6500 then?
I don't remember. I don't think so. I saw a lot of. There was an Alto. There was all sorts of amazing stuff there.
Yeah, they're restoring a Control Data 6500 mainframe, and they have to rewire the chassis together, and it looks like they're making really good progress on that. Wow. That's quite a job because it requires 400 cycle power and water cooling and all kinds of stuff. And I told them their light bill will go up by $10,000 a month once they turn it on.
I don't think they'll mind. They can
Yeah,
afford
that's
it.
what they said. Paul Allen won't care.
Yeah.
I did find they had a big chart on the wall of computers and their relative speed. And one of them shorted the 6600 by 3 orders of magnitude. They had it down as 2,904. And of course, it's really 2.9 million. Whereas they had the 7600 right at about 8.8 million. I don't know how that got so wrong. It kind of stood out, and it's such a significant machine, it really should be right.
Did you catch the problem?
Oh, yeah, of course. And I told everyone that would listen that they got it wrong. It was interesting, some of the blind spots. I was surprised they didn't have as many CDC mini computers. They didn't include the 1700, for example, or the 8090. But, oh, well, whatever. It's hard to get everything.
Right.
But a machine as prominent as the 6600 really should have the numbers right. So, anyway.
Cool. This is great. Yeah, any source code you can find for anything. My Apple people would kill me if I went, oh, you've got a MECC source code for Apple and whatever. If something isn't out there, then it's my job to help make it out there, get it out there, and sometimes just have to ask. So,
yeah, I don't think I have any Apple source code from MECC at all. I'll check. I just might have some library routines, but that's probably, well, unless you're going to use it to make some new software, it may not be very
There are plenty of retro computing hobbyists out there that are doing that sort of thing, and you never know.
Okay. Okay. I'll see what I can put together, and some of this is interesting because there's an emulator for the cyber out there, and it emulates the entire machine.
Wow.
And actually, runs amazingly. PLATO runs faster than it ever ran on a real computer on the emulator. And one of the reasons they were able to bring it up and do so much with it is I had saved a Dead Start tape from when I was at MECC. And so actually a lot of the people running the emulator are running a heavily modified operating system that I worked on. So when it first came up, I got to answer a lot of questions. Because they say, well, this doesn't work like in the manual. Well, yeah, we changed it to work like this. Really, there's a good reason for it. But unfortunately, I would be compelled to bring that system up if I had all the software that went with it. But I only saved the system software, and that's just not that compelling.
Can't do that much with it, right?
Right. Yeah. Need to have Oregon Trail and all the library stuff, and I don't have it. I couldn't shake loose enough tape to have all that. But I think there would be more people interested in it if I had. But it's serving a purpose even as it is. So, that's something.
Awesome. Thank you so much. This was a great interview, and I enjoyed talking to you.
Great. Thank you.
Thank you. Good night, Mark.
Yeah, good night.